Before we start section 7.7, exponential growth, let's start with a warm-up. You purchase an item for $50. What is the final price you pay, including sales tax, which is 8%? We need to remember that before you put a percentage into an equation, it must be converted into a decimal. A percentage is a number out of 100. So we can divide 8 by 100, which will give us 0.08, or we could start with 8 and move the decimal 2 places to the left. Our purchased item is $50. We need to multiply the price by the sales tax, which is 8%, to find how much money we will owe for tax. When we multiply these two numbers, we get $4 in sales tax. Then you would need to take the cost of the item and add the sales tax to find your total cost of $54. We could use the exponential growth model as an easier way to find our total price. We need to think of the fact that we will pay 100% of the item plus 8% in sales tax. So 100% plus 8% means we are going to pay a total of 108% of that price. So we're going to pay 108% of $50. We'll first convert this percentage into a decimal. The decimal is after the 8, so we'll move it to the left 2 places. This would be 1.08. If we take the $50 item times 1.08, we'll go straight to the amount we pay for the price plus the sales tax. 100% of the $50 plus 8% gets us directly to a total of $54 for that item. In section 7.7, we discussed exponential functions, both showing exponential growth and exponential decay. In section 7.7, part 1, we are going to focus just on exponential growth. Please pause the video and copy the definition. We're going to start with an example. Let's say you deposit $500 into an account that pays 8% interest compounded yearly. When a bank or financial institution pays interest on both the principal and the interest earned, that's the definition of compound interest. We need to find how much money you would have after 6 years. At year 0, we're going to start with the $500. Then, after the first year, you are going to get 8% interest on the $500 you deposited. So you're going to get 100% of your $500 that you deposited, plus you're going to get 8% interest, for a total of 108% of the $500 you deposited. We're going to convert that into a decimal. Remember, you put your decimal in at the end of a whole number and move it 2 places to the left. So this is 1.08, 108%. So I have $500, and I need to find what 108% of that $500 is. That tells me at the end of the first year, I will have $540. Starting the next year, I will begin with $540, and I will then get 108% of that $540. When we type this into our calculator and round to the nearest penny, we have, at the end of the second year, $583.20. I'm going to start my next year with the $583.20, and to find how much I have at the end of the third year, again, I'll multiply it by 108%, and I'll find that at the end of the third year, rounding to the nearest penny, I have $629.86. I'd like you to continue this pattern and finish the table. Pause the video and do that now. When I finish the table, I can see that I will have $793.44 at the end of the 6th year. But there has to be an easier way to find that. We can use the exponential growth model. Remember, exponential functions look like y equals a times b to the x power. A is our starting amount, so I'm going to plug in $500 for A. B is how much it's growing by. Each time it's growing by 1.08 or 108%. 6 would be how many years it's growing by that amount. So 6 will become my exponent. And y will be the amount of money I have after 6 years. If I type just that in my calculator, I can get an answer of $793.44. So we're going to continue to use the exponential growth model today to find these values much quicker than making a table as we did in this example. In section 2 of your notes, let's again copy down the exponential growth model. Remember, y is our total. A is the initial amount, which is called the principal. Remember, if we were to graph, this is our y-intercept. The b value, if it's a growth factor, needs to be greater than 1. And remember, we're going to take 1 plus the growth factor as a decimal because you're going to get 100% of your initial amount plus the percentage of growth. T, our exponent, is the number of periods of change. Think of T as the amount of time that your money's growing, that it's in an account, or the amount of time that has gone by if we're looking at populations of animals or people. Exponential growth is not limited to problems about money. Here's one regarding population. In 1998, a certain town had a population of 13,000 people. Since 1998, the population has increased by 1.4% per year. Write an equation to model the population increase. Let's refresh our memory as to how to change percents to decimals. Practice these. What would 40% be as a decimal? Remember, it's 40 out of 100. If we divide 40 by 100, it moves that decimal 2 places to the left. 40% would be 0.40. How about 4%? We move the decimal 2 places. There's a blank spot, so add a 0 in. 4% would be 0.04. 10% would be 0.1, but 1% would be 0.01. 140% would be 1.4 or 1.40. So in this problem, before we put our decimals in, our percentages in, we have to change them into decimals. We're going to take the 1.4% and we're going to make sure that we move the decimal 2 places to the left. It's going to go in as 0.014. Pause the video and try to write an equation to model this situation about population increase. My initial amount was the 13,000 people, so I put 13,000 in for A. Then I had to take 1 plus the 1.4% or 0.014 so that I was considering 100% of the population plus the increase of 1.4%. When I add those amounts together, I get my final equation of y equals 13,000 times 1.014 to the t power. In part B, they want us to use our equation to approximate the population in 2006. We need to think of how many years have went by. From 1998 to 2006, if we subtract those years, we can see that 8 years would have gone by. So our t value is going to become 8. Use the equation, plugging in 8 for t to find the population in 2006. Pause the video and do that now. You should have gotten this decimal as your answer. If we're talking about a population, we're talking about people. So we could say, since the problem says approximate, about 14,530 people. Example 4, a $5,000 investment makes 5% annually. What is the balance after 1 year, 2 years, 3 years, and 20 years? Let's first do section 4A. Write the equation to model this situation. We have a $5,000 investment. So where would that go? Well, that's going to go in for A because this is our initial amount. It's going to make 5% annually. 5% as a decimal would be what? You should move your decimal point 2 places to the left and show 0.05. Pause the video and write your equation for part 4A now. You should have 5,000 times the quantity 1 plus 0.05, all raised to the t power. It's 100% of the money you deposit plus 5%. And when I simplify, I get this for my equation. Now for parts B, C, D, and E, we're going to use that equation to find our balance after a certain number of years. So for part A, I'm going to put 1 in for t and solve to find the amount I have in 1 year. For part C, I'm going to plug a 2 in for t into my equation and find the money after 2 years, and so on. Please pause the video and complete parts B, C, D, and E on your own. Please make sure that you've rounded each of your answers to the nearest penny, which would be the hundredths spot. What would happen if a bank paid interest instead of annually or once a year? What if they paid it semi-annually or quarterly? Would that be a better deal than annually? Please watch the second video for your 7.7 exponential growth notes to find out.